Hello and welcome back. For this video, we're discussing section 3.1, representing relations. Here you can see what the learning goal is supposed to be. Students will represent relations with graphs, ordered pairs, tables, and mappings. This is a 2-day lesson, however, this video will cover both days. There is a PDF attached, so you can download this and print it out and follow along with the notes and add some things to your notes as we go through. Well, first we need to take a look at some vocabulary. So a relation is the pairing of any two numbers, typically as an ordered pair. So I have a couple of relations set up here. The domain is the set of input, also known as the x values of a relation. So given this relation right here, the domain is -2, 3, 5. And notice how I put it in smallest to largest order, so it's a numerical order. Now when we look at the range is the output, or this should say y actually, y values of a relation. So I've got the same relation here, and notice the range value. Notice how I have only the -6 showing up once. We only list the actual range value once, even though it shows up twice in the relation. And then we have another way of expressing it, which is a mapping. And mapping is simply an illustration to show how each element of the domain is paired with an element of the range. So left-hand side here, and we usually do it on the left-hand side, is the domain, and also domain again is the x values. And the right-hand side would be the range, which would be the y values. And notice how I put these in here from top to bottom, least to greatest, and I do the same thing on the range side. Now remember, up here we had the range listed only two numbers. Again, we have two numbers here as well, and that's because the number -2 and the number -3 both map to that same point. So they show the relation between the domain of -2 and a range of -6. We do not need to show the range -6 twice in a mapping. You can also make ordered pairs from this. So the -2 goes to the -6, so there's an ordered pair. And then the 3 goes to the -6, so 3, -6, and 5 to 7, so 5, 7. So you can make your ordered pairs right from the mapping as well. Another name for domain and range, x and y, would be input and output. And I mentioned that up here in the top, input and output. A little more vocabulary. We have independent variable and dependent variable, and if you're paying attention in science, you'll notice that we use those words a lot in science. Independent variable is usually the x value in a relation that is subject to choice. So what does that mean? Well, it means you pick a value for x, or the independent value or variable itself. So you get to choose that one. The dependent variable is usually the y value in a relation, and that depends or changes as the value of x or the independent changes. So in other words, you calculate the value of y or the dependent variable only after you choose an x. So you choose an x, that's your input, and then you have an output also known as the dependent or the y value. Now scale is referred to on graphs. So that's the distance measurement between tick marks on the x and y axes. So the tick marks would be, for the x's, would be these lines that go vertically like this, and the tick marks for the y-axis would be the lines that go like this. Okay, so on this particular graph, which shows years since 2008 and the average post per day in millions of social media posts, the x scale is 1 mark is equal to 1 year. So from here to here is 1 mark, and that 1 mark is equal to, as you can see, 1 to 2 is 1 year each time. The y-scale is the difference or the changes between each of these horizontal marks, or tick marks, whatever they want to call them, and you'll notice that it's going by 50s, and it is in millions, so 1 mark is equal to 50 million posts per day. So today we're going to be talking about 4 ways of expressing a relation. We've already seen one of them, which is a mapping. So we've got the domain, and another way of expressing the domain is called the x, and the range would be a y, or we could call it input, and this one we call output. And we just have 3 numbers that are mapped together. So 3 to 5, which I could call 3, 5 as an ordered pair. -4 maps to -2, which would be -4, -2. And then the 0 maps to the 2, so I'd call that 0, 2. Another way we could express it is using a table, and we almost always put the x on the left-hand side. So you notice you got the same 3 x's here that you had over here, and the same 3 y's that you have here in the original range on this side as well. Another way we can express the relation is putting it in a graph. So if we look at this point right here, that point is located at -4, -2. This point right here is located at 0, 2, and this point right here is located at 3, 5. Notice these numbers are showing up here, here horizontally, and they're showing up on the graph. We could also express them as an equation. You see we have an y and we have an x. That's an input-output. So you input a number for x, you do some calculation, and it outputs the appropriate value for y. So we'll show how that happens. So if we go back to let's use the table because we often do this in a table. So if we look at the table, our first x value, our first domain or input value is 3. So if we were to substitute x with 3 and then continue calculating, we'd have y is equal to 3 plus 5, or 3 plus 2, which is 5, and you see this 5 matches that 5 there. I could do the same thing with the -4, so y is going to equal, we input the domain of x, which is -4, plus 2. So this is a rule that says add 2 to every x, and that's how you get the y. So the y then would equal a -2, which again, this one matches the same output. Okay, so two more things we want to look at. Number one would be creating an appropriate scale, and the other one's going to be dependent and independent, or versus independent on a graph, identifying which one's which, and maybe interpreting the graph a little bit. Anyway, we're looking at creating an appropriate scale. So if we look at the values that we have here, you'll notice that these numbers are pretty large. And if you look at our graph, we only go 10 this way, -10 this way, +10 this way, and -10 this way. So we only go 10 in all directions. So we have to make sure that there's enough room on this graph to include every data point that's listed in our information here. So what we want to do is take a look at the x values. We want to find the smallest x value, so like an x min and an x max, so the largest one as well, so x max. So looking at our information, our smallest x value appears to be a -36, and our largest one appears to be a +38. Do the same thing on the y values, so y min and your y max, and the smallest y value appears to be a -91, and the largest one appears to be a +95. So what we want to do is find the change between the smallest and the largest x max, and the change between the smallest and largest y max. So the change in the y value, or the x values, is going to be, by the way, let's call this, let's simplify this a little bit. So this -36, how about we just call that -40, because we want to go low enough to include the -36, and the 38, we want to go high enough to include that, so let's round it off to, let's say, 40. So the distance between 40 and -40, over here we're going to write as 80. So we have 80 across, and we're going to do the same thing for the change in the y values. So the change in y values, I'm going to make this -91 small enough to include that, so I'm going to go to -100, and the 95, I might as well go up to +100, and then find the change between those two numbers, which should be 200. And as I said earlier, we're going 10 this way, 10 this way, 10 this way, and 10 this way. So what's the change across our x values? Well, we've got a total of 20, 10 to the right and 10 to the left. So what I'm going to do is I'm going to take my change of 80 and divide it by how many vertical tick marks I have, which is 20, and comes out to approximately 4. Now I'm going to make the math a little bit easier, so I'm going to go by 5s. I'm going to round it up to 5s, because counting by 5s, let me change that this way, because counting by 5s is a lot easier than counting by 4s. So if I go bigger but not smaller, I will have enough room to show all the data points from -36 to +38. I'll do the same thing right here with the y values, so I still have 20 up and down, so if I divide that out, that comes out to exactly 10, which is a nice number. These two numbers do not have to be exactly the same, but they do need to be appropriate so that you can fit every data point on the graph. So our x scale will be 1 mark is equal to 5. Now I don't have units on there, so all I can do is say 5. And our y scale is 1 mark is equal to 10. And what that means is if I go on x's, this is 5, 10, 15, 20, 25, 30, 35, and then over here I hit 40. And our y scale is 10, so I'm going, let me get this out of the way. If I go vertically, we go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 up here at the top. And now when you go to plot these points on the graph, you'll have enough room for all data points. Okay, dependent versus an independent. Now, what we've said before is dependent is usually the value that you can choose, which is typically the x, and the independent is typically the y, and that's almost always calculated. So this is showing us the text messages sent, and that's on the y-axis in time. So the amount of text messages you send really depends on how much time you have to send them. So that's why we say the time value is the independent, and the text messages here will be the dependent. Now, if we were to interpret the graph a little bit, we can also see that as we go from left to right, we are sending a steady amount of text over a certain amount of time. Then all of a sudden we hit this horizontal line, and that means we stop sending text for whatever the change is between here and here for that duration of time, because you see that goes down here to the time value. So whatever that is, that duration of time, we sent no text. And then we started sending text again as we go up the line again. And then we have this huge gap right here where we are sending no more text. And of course, that's a larger amount of time. And then we start to send text again. And it looks like with that arrowhead, we never stop. Now, one thing you can also tell on this graph is where that you started sending text at a faster and faster rate. Well, look at the three lines that are actually increasing. And you'll see that one of them is actually steeper than the other. So that's this one over here. So that could be like early in the morning, and you're sending most of your text at the fastest pace anyway during that time.